Hello everyone, I am Soumyashree Senapati, Assistant Professor Civil Engineering. So, we have already discussed soil mechanics, but in this class we will discuss index properties of soil. So, what is the necessity to know about index properties? Like soil index properties, it gives us how to identify and classify the soil for engineering purposes. So, there are two terms like identify and classify. Let's take an example of chocolates like Dairy Milk and Kit Kat. So, how we identify that? By their taste, by their shape, and by the consisting materials inside the chocolates. Also, we classify them by what? Like 10 rupees Dairy Milk, like 20 rupees Dairy Milk. But what is the difference there? Their sizes. Okay, in case of 10 rupees Dairy Milk, there will be some small size. In case of 20 rupees, there will be little greater size. Okay, so like that, our soil size also varies. Okay, so in case of when soil size varies, so it will be classified into with what? Our IS classification system. This classification we will discuss later, but what we will study here, like we need two properties, like one is soil aggregate properties and another is soil grain properties. In case of soil aggregate properties, it depends on what? Soil mass as a whole. Like when we discuss about soil aggregate properties, so we consider the whole mass of soil. Okay. So, in case of mass of soil, what happens? Like the various sizes of soil is present in that case. And in case of soil grain properties, what happens? It depends upon soil grain size, shape and etc. So, soil size depends on like if the soil size is similar. Okay. If these sizes are same, okay, so it will turn as what? Uniform gradation, uniformly graded soil. Okay, so if the soil is like one sample is like this size, another one will be small, another one will be small. Okay, another will be greater. So what happens? In this case, we said it as what? Poorly graded soil. If one size is present, bigger size, and one is smaller size, the medium part size of parts is missing there. So what it will term as what? Gap graded soil. Okay, so also in this part also we will discuss later in a better way. Okay, so now what we will discuss about their shape and size, like grain size distribution. What it helps to find gradation and uniformity. Like if here is the what size chart of different size of soil. So according to their size, we have named different names for according to their size. Okay, so separates out soil into different fractions based on particle size. Okay, so the particle size, based on their particle size, we have separated their names. If the size of particle is greater than 300 mm, we termed it as boulders. Okay, next, what we need to remember these terms. Okay, we will use these again in case of when classification of soil is necessary. Okay, so next, what 80 mm to 300 mm soil size is termed as our cobbles, CO. Next 4.75 mm to 80 mm. that will be our gravel, G. 75 micron to 4.75 mm, that will be sand. 2 micron to 75 micron, that will be silt. For silt we take as M. Less than 2 micron is clay. So this gravel, sand, silt, clay, these 4 is more important. Okay, in case of we need to remember this. Okay, so if the soil size is in between, if soil size is greater than 300 mm, right? So we will term that as what? Our boulders. So if we know this size, so if we see in case of we are going outside, so we see any size of soil, any particle size, difference between particle size. Like so, what we will term? Yeah, there is some cobbles are there, there is some sand. Okay, by this size we differentiate their names, right? So okay, we need to remember these 4 mainly. Also these are necessary, but these are very important, right? So next is what? Okay, so grain size distribution is generally of what types? Of one is coarse grain soil and another one is fine grain soil. Okay, so generally we do grain size distribution in case of these 4, like gravel, sand, silt and clay. Excuse me. So when soil particle passing through 75 micron sieve size, that will be termed as fine grain soil, right? If passing, right, passing sieve size is 75 micron, so that will be termed as fine soil. Next is what? If soil passing through if soil retain in 75 micron sieve, that will be termed as, that will be our what? Coarse grain soil. Okay, one is coarse grain soil, another is fine grain soil. So in case of coarse grain soil, what? One is gravel and sand, and here in case of fine grain soil, what? One is silt and another one is clay. But also here in case of sand, there is coarse sand and fine sand. We will describe that later. So how to differentiate these things? In case of coarse grain soil, we differentiate this soil like what? By using sieve analysis. I have used this word like sieve. What is sieve? So here you can see these are the different sizes of sieve to separate all types of soil. Okay. And as fine grain soil are very minute, okay, very small. So what happens? They just connect with each other. So we can't just sieve analysis that. So we use sedimentation analysis for fine grain soil. So what is sieve analysis? Like what it says, sieve vary in size in between 80 mm to 75 micron. Okay, so like if the first one will be our what? 80 mm sieve size. Okay, a set of sieve what? 80 mm, 20 mm, 10 mm and 4.75 mm. These are the sizes of sieve is required to for the fractioning of gravel. Like we know that if soil is retained in between what? Here we have the size for gravel it will be 80 mm to 4.75 mm. 4.75 mm, right? But what happens? In between 80 mm and 4.75 mm, there will be 80 mm sieve, 20 mm sieve, 10 mm sieve and 4.75 mm sieve. So, what? 80, 20, 10, 4.75. So, to differentiate gravel, if the soil is passing between 20 mm sieve and retained in case of 10 mm sieve, we also term that as gravel. Okay, understand? So, next is what? For further fracturing, like we have known that this is gravel, but which type of gravel, like coarse gravel or fine gravel? If it is passing through 80 mm sieve but doesn't passing through 20 mm sieve, it will be our coarse gravel. Like, okay, so here COARSE, never write the spelling as COU. It will be coarse, CARSE, that will be our coarse grain soil and fine grain soil. Okay, so next is what? The set of IS sieve. Like these sieves are classified according to Indian standards. So we have termed that as IS sieves for fine sieve analysis. These are for what? These are for coarse soil. Okay, these sieves are like 80, 20, 10 and 4.75. And for fine sieve analysis, what? Here you can see 2 mm, 1 mm, 600 micron, 425 micron, 212 micron, 150 micron and 75 micron for separating fine aggregates. Okay, so how this sieve analysis occurs? Like here we put the 80 mm sieve. Next is our what? 20 mm sieve. Next is our 10 mm sieve. Next we put 4.75 mm sieve. Okay, these are for what? For coarse soil. So what happens after 4.75? We will put here 2 mm, then 1 mm, then 600 micron, right? Then 425 micron. Likewise, this last we will put one pan. In case of pan, there is no pores, so that the all passing soil in will be placed here in case of our pan. So we will put our sieve in this manner. So what happens now? If we put 100 grams of soil, okay, so this 100 gram of soil will pass in between this 80 mm sieve. So we have already given here what? 100 gram. So we will see, let 75 grams of soil will pass through this. Okay, so what amount retained? Like 100 minus 75. Okay, 25. 25 grams of soil retained in case of 80 mm. 25 grams soil retained in case of what? 80 mm sieve size. Okay. Next what? Next, from these 75 gram, so the passing soil will be 60 grams, right? And what left? 15 gram will be retained in case of 20 mm soil. Okay. So this 60 gram retain, this 60 gram passing through this sieve, like 20 mm sieve, will be classified as what? Our D60. Okay, so D60 will be termed as like 60% soil passing, soil finer in Okay, here 60% of soil finer in which sieve? In 20 mm sieve, right? So we will get this D60 value. Now from this 60 gram, here 30 gram pass and 30 gram retains. So also by this manner we will get our D30 value. Okay, so like we can write 30% soil finer than the other soil is D30 is what? If it will retain in case of 4.75 mm. So our D30 will be 4.75, right? So like in this way we will get our what? D60 value, D60, D30 and D60, D30 and D10. So in next class we will discuss why we need these values. So we have understood sieve analysis. So what is sedimentation analysis? Okay, so here sedimentation analysis is done for fine grained soil. So as the gap between particle is very less, there is pipette method for sedimentation analysis. So we will discuss briefly about sedimentation analysis in our next class. If you understand this video, then like, share and subscribe. Thank you.